Okay, so this is section 3.1. This is part 2 of the assignment. We're going to be talking about end behavior, which I talked a little bit about in the first one. I'm going to elaborate on it some more here. We're also going to be talking about something called intermediate value theorem and graphing without technology, which is something you're going to need to start learning how to do. Okay, so in behavior, we talked about this a little bit in the last one. It's how the polynomial looks when x gets big in the positive and negative directions. Okay, so let's take a look at a couple of polynomials. So let's take a look at 3x to the third minus x squared plus 5x plus 1. Okay, so here we are. Let's zoom out on it a little bit. Now remember, we are looking at how this function behaves as x gets very, very, very big. So this is as x goes to infinity. And over here is as x goes to negative infinity. Okay, and if we continue to zoom out till we get some really, really big long numbers, and it's not going to do it. Anyway, what's happening here, so as x gets big, you notice that your f of x, your y, also gets big in the positive direction. So there's that in behavior. Let's come over here. So as x gets big in the negative direction, you notice we're growing unbounded in the negative direction. So f of x or y is also going to go to negative infinity. Okay, so now let's take a look at another equation. And I just want to take a look at x cubed. And there it is. Okay, you can still see faintly my other one. Now, the reason we've got this put on, you notice that down here, these things look very different. But if you look at the end behavior is the same. And the reason being, as x gets really big, for instance, if we let x equal 9 times 10 to the 121st, That's a really big number. When I cube that, now we go from 121 zeros to 363 zeros. So what you see is happening is that x gets big, the highest order term is what will take over from us. So for this equation right here, my little parent, again, as x goes to infinity, y goes to infinity for this guy. And same thing down here. As x goes to infinity, negative infinity, y goes to negative infinity. So in behavior is basically governed by highest order term. And the reason you get a negative here is when you cube a negative number, you're going to get another negative number. So the important thing here is to remember is that we're interested in the highest order term, and we're interested in what happens as it gets very, very, very big. Okay, next topic I want to talk about then is the intermediate value theorem. And this is going to become important to you also. So if I come in and let's draw an equation here. I've got a graph. That's 1, that is 2. All right. So I know at x equals 2, my function is 3. X equals 1, my function is negative 1. What the intermediate value theorem tells me then is if I have a change in sign in my function, my y values, then somewhere between this point and this point I've got a 0, at least one 0, which is right there. We're assuming it's continuous. What this looks like on your table is you'll have x and y, and when you come in, you'll see 1, negative 1, and then you will come over and you will see 2 and 3. Now notice the change in sign. So because we're going from a negative to a positive, at some point or other we're going to have to go through 0. So what this tells me is that somewhere on this interval, so somewhere between 1 and 2, on that interval, we have a 0. Okay, now this becomes important when we come back in, and you're going to have to graph polynomials without a calculator. You will have to do this on a test. So I suggest you start practicing it now, because I will have you do this on a test. You will be taking a test, and you will not be allowed to have a cheat sheet, and you will not be allowed to have a calculator. I'm going to make you graph a polynomial. So what you do, you graph polynomials. Number 1, you find your zeros, which are your x-intercepts. And this is usually done by factoring. Remember, you're not going to be able to look it up on your calculator because you don't have one. The second one, you're going to have to build a table like with inequalities. and choose test points. Now the reason you're doing this, and it's actually a really slick trick, is for your test point, which you remember somewhere in your interval between your zeros. So if the y value you get, the function value, is positive, that means it lies above the x-axis. All right? Those are positive y. So that means is that over, let's say, this particular interval, we have a 0 here and we've got a 0 here. If it's positive, that means it's going to lie above the x-axis, but it's still going to have to go through these, so it's going to look something like this. We know it's going to be above it rather than below it because you got it using your table. So for your test point, if the y is a negative, then it's below the x-axis. And let's say I've got another negative 0 over here, and over this interval it's negative, so I know it's going to be below it. Now you don't necessarily know what these values are, but you can sketch a relatively accurate graph even without knowing that. So the third thing you're going to have to do is look at end behavior. And what that is, if I know, for instance, on this one, as x goes to infinity, y goes to infinity, and as x goes to negative infinity, y goes to negative infinity. So I can come over here, and I can use this one here, and I say, okay, as goes to infinity, my y is going to get a big positive. It's going to look like that. It's just going to go up and up forever. Then I come over to this one, and I'm saying, okay, now on this one, I'm going down. If I was going up, then I would have to come back and do that. But we know it's going negative, so we've got this guy right here. And then the last thing you do then is what I have been doing, which is sketch a smooth curve. And this is called connect the dots. Okay. So let's take a look at how we're going to do this. Let's work an example. My function is going to be x cubed minus x squared minus 6x. Should recognize this guy by now. We've seen him a lot. So the first thing I need to do is find my zeros, which means I'm going to have to factor. That's a cubic, that's bad, but fortunately I've got an x in both of them, so I'm going to factor whatever I can out of all my terms. It's going to be x times x squared minus x minus 6. And if you redistribute this, you'll see we end up with that. Okay, so now I continue at x. You should be able to factor this guy, x minus 3, x plus 2. So now I'm going to do that. I know where my zeros now are going to be at 0. That's from this term. This term gives me a 3, and this term gives me a negative 2. So there are my zeros for this polynomial. Okay, so now I go in and I set up my table. So I know I'm going to have negative 2, 0, and 3. And I'm going to pick some test points. I'll do negative 3, negative 1, 1, and 4. So I've got my factors, which are x, x minus 3, and x plus 2. So now I plug my test point in. This gives me a negative here, a negative here, a negative here. Negative times negative makes my result a negative, which means that this is going to be below x-axis. So anywhere to the left of negative 2, I'm going to be below the x-axis. So now I pick my test point in the middle here, negative 1. That's going to give me a negative, and a positive. Negative times negative is positive, times a positive is a positive. So here I know I'm going to be above the x-axis. Then I plug in the point I've got here, 1. Give me a positive here. 1 minus 3 is a negative, and a positive. That's a negative, so I'm going to be below. And then the final one is plug in my 4. That's going to give me a positive, and a positive. That tells me I'm going to be above. Okay, so last of all, let's come in and let's take a look at the end behavior on this thing. And like I had just talked about before, you come in and you look at your highest exponent, which is x cubed. So as x gets big for x cubed, my y is also going to get big also. As x gets very big, the negative numbers, negative times a negative, so remember x cubed is x times x times x. So negative times a negative is a positive times another negative. So y will also go to a negative infinity. So at this point now, we've got where our behavior is and how it looks. So now let's start to actually sketch this thing. Here's my graph. I know I have a 0 at negative 2. So that's 1 point on the graph. I also have 1 at 0. That's another point on the graph. And I have 1 at 3, which is another point on the graph. Now we don't know how to connect these, except we come back in here, and I know that everything to the left of negative 2 is below the x-axis. And I know at my end behavior, it goes to negative infinity, which means it's just going to drop off. So this guy is just going to go down somehow. Okay, so now we've got to go between here and here, but we don't know whether connected below or above. So we come back over here. This tells me I'm above the x-axis. So everything in here is going to be above the x-axis, and we come back down. This is going to be below, so between 0 and negative 3, I'm below the x-axis. So I do this. And then I notice above here, I'm back above it again. And I look at my end behavior, which means it's just going to continue to go up. And so there it is. Now, we don't have a good feel necessarily on what these things are, but we still have a relatively accurate sketch of what this thing is going to look like. And oftentimes, that's just as important. So while I'm doing it here, let's take a look at what's happening here and here. You'll notice that we're actually changing directions. This thing was going up, and now it's going down. This is called a local extrema. And a local extrema is just where the function changes direction. It was increasing, and it went to decreasing. Here it was decreasing, and now it goes back up to increasing. So this is also a local extrema. And this is going to be a maximum value. because you see it doesn't increase. This is the maximum value locally here. Now I know we get bigger over here, but this is why it's the term local, just over this interval. And this will be a local minimum, right here. Okay, so we come back down, and that's the smallest it is, at least over this interval right here. Now you notice we don't have any local extrema here because we don't change directions. They just keep going up and up and up. Okay, so let's take a look at another equation. P of x is going to equal to x minus 2 squared times x plus 1. What this means is that this 0 occurs twice. What it means for your graph is it's going to come off of this one and basically bounce. I'll show you what this looks like. So now I've got a 0. My zeros here are at 2 and negative 1. So I'm going to build my table. There's negative 1. There's 2. I'll pick a point right here of negative 2, 0, and 3 for my test points. So I've got an x minus 2 squared and x plus 1. I plug negative 2 in. Because I'm squaring it, these are all going to be positive. Negative, that's a negative, so this will be below the x-axis. Okay, now x squared times x from this one will give you an x cubed term. And x cubed you should recognize as x goes to infinity, y goes to negative infinity. I'm looking at any behavior here. That means x goes to negative infinity, y, goes to negative infinity. It should be a positive. Okay, so now I'm going to come back down here. My test point of 0 will be positive, 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 so that's above. And I've got a point of 3. So this will be 3 minus 2 squared will be a positive, positive. So this one is also above. And I'll show you what this looks like. So at this point now, we've got our zeros and we've got our in behavior, so we can start sketching my graph. Okay, so I've got zeros of negative 1 and 2. Okay, down here, I know I'm below it. I'm going to negative infinity, so this guy is just going to drop off. At this point, we don't really know what it is. We know it's going to drop off. Between here and here, I'm above it. Between here and here, I'm going to be above it. It's got to come back down. Okay, now I also know that I'm above it here. So that means is this thing has to come back down, and then it's going to bounce off and go back up. So it will just touch this point, bounce off of it, and then go back up, because my end behavior is telling me that I'm going up and up and up. So this is how you're going to sketch these things. What I suggest you do on these is you actually, on your homework, is sketch these this way, because you're going to have to do it on a test, and then check it with your calculator.